Yeah, I'm going to go over two problems from the first homework assignment now. These are even numbered problems that don't have solutions in the back of the book. Pretty much all of the odd numbered ones do have solutions in the back. And these two problems that I'm going to go over, 5.10 on page 272, and then we're going to go over 5.14 on page 273. Some of you guys, made mistakes on those, so, we just want to clarify, the correct way of solving them. So in 5.10, we were told that, there's a video rental store, and they have a certain amount of movies, and they tell you what the probabilities are if you rent movies at random. The probability of getting a movie that's rated G is 0.26. Probability of getting a PG movie is 0.21. And probability of getting an R-rated movie is 0.38. Now part A asks us, what's the probability of getting a movie that's rated G, right? And they already gave that to us in the initial part of the problem. It's 0.26. Right, so that's not bad. Some mistakes people made is they were writing 0.26, out of some other number. It's okay to leave a probability as a fraction, with an integer over an integer, right? So we could also have written this as 26 out of 100, or we could have expressed this as 26%. Any of these would be correct. I'm sure that also simplifies, and whatever that simplifies to would also be okay. Now let's get to part B, where, some people had made mistakes. So this one's a little bit tricky. So here they said, find the probability of getting a movie that's rated something other than G, PG, or R. Now, a way that we could write it is like this. This means the probability that whatever movie we get is not rated G, it's also not rated PG, and it's also not rated R. So it can't have any of these ratings. I don't know what it's rated, but it's not rated one of these three things. Okay. So in order to do that, this is going to be, right, 1 minus, this is like the complement of the probability that we get something rated G, PG, or R. So we can do 1 minus the probability that it's rated G, PG, or R. Or G or PG. Yeah, we put extra ors in here. Okay, so not G or PG or R. To find that probability, we're going to subtract the probability that it's G or PG or R from 1. So the probability of this, we get a movie that's G, PG, or R, we can just add these three probabilities together because these are mutually exclusive events. You can't have a movie that's simultaneously rated R and also G, and you can't have a movie that's PG and R, or a movie that's both PG and G. A movie can only have one rating, so there's no overlap between any of these. So the probability here is going to be 0.26 plus 0.21 plus 0.38. And this works out to be 1 minus 0.85. So our probability here is going to be 0.15. Right, so we also could have written this as 15%, or we could have written this as 15 over 100. Okay, now the next one that we have here is like an easier version of this problem. Here they're asking us to find the probability that a movie picked at random is rated either G or PG. If, and again, we are going to make use of the fact that these are mutually exclusive events. There's no overlap between them. So this probability is just going to be equal to 0.26 plus 0.21, and we're going to get 0.47, which we also could have expressed as 47 over 100, or we could have expressed this as 47%. Okay, now let's move on to the next problem. Okay, so this was a problem about dice. The first thing that they asked is they said to draw out or list the sample space for rolling 2 dice, or you were rolling 1 die 2 times. It doesn't matter. They have the same sample space. Okay, so a number of you guys listed the sample space out incorrectly. You treated it as if they were dependent events instead of independent events. So if we look at what's going on here, when you roll 2 dice, right, you can get the same number on both of them. you're not going to end up in any type of a situation where once you roll 1, you're never able to roll 1 again, right? If you roll a die twice, you can land on 1 2 times, or if you roll 2 dice, you can get 1 on both dice, right? So you need to take that into account when you're listing out your sample space, that you can get, numbers, they can repeat like this. Okay, so this is the sample space we have here. Again, the sample space also showed up, I think, in the last problem in the video on the video we had on sample spaces. There was another dice problem there. So this problem is similar to that one. Okay, so let's look here. The probability of first getting 2 1s. Well, we can circle that right here. There's only one way that that can possibly happen, right? So this is going to be 1 out of 36. Right, and again, it's important to stress that, there's 36 possible outcomes here. Okay, so this means our probabilities should be out of 36. Okay. Now we want to find the probability that, the way the book worded this is 5 is on one of the dice and a different number is on one of the other dice. So again, this is one that's kind of hard to try and list all of the possible ways that can happen. But if we have a sample space over here, what we can do is search for places where that happens. So we want, one number, right? So here we have a 5, and then here we have a number that's not a 5, right? Similar over here, here, that's another one. So these are all of the ways where we can roll, right? Everywhere here we have 5 on one of the dice and we have a different number on the other die. Okay, so now if we count this up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 10 different ways that that can happen. So our probability here is going to be 10 out of 36. Okay, so the next problem is asking for finding the probability that the sum on the 2 dice adds up to 7. For this one, what we want to do now is, again, this is like the problem we did on the other video, right? If you've listed your sample space out in this manner, we can easily see what the sums on the different dice are, or pairs of numbers on dice are if we go across the diagonal. Like here, 1 plus 1 is 2. 1 plus 2 and 2 plus 1 is 3. 1 plus 3, 2 plus 2, and 3 plus 1 all add up to 4. 1 plus 4, 2 plus 3, 3 plus 2, and 4 plus 1 all are going to add up to 5. This next diagonal all adds up to 6. And then everything along this middle diagonal adds up to 7. So the answer to part C, we need to see how many possible outcomes there are here. Okay, so we have 1, 2, 3, 4, 5, 6. We have 6 different ways that that could happen, or that we could get 2 numbers on the dice that add up to 7. So 6 out of 36 is this probability.